The latest research findings suggest that there is a high probability that the Milky Way and Andromeda will not collide. The Milky Way is a giant spiral galaxy composed of hundreds of billions of stars. It's traveling at about 110 kilometers per second. Fly towards the Andromeda Galaxy. About 4 billion years later, these two giant spiral galaxies will collide head-on, eventually merge into an elliptical galaxy. New names have been given. It's called the Silversius Galaxy. Does everyone think this is a ding-talk thing on the board? It will definitely happen. But now Hubble, and new observations from the Gaia telescope, plus what was ignored before, the attractive forces of small half-galaxies. But it points to a very different future. The collision that was once assumed to be inevitable, maybe it's not so inevitable at all. 2012 Hubble Space Telescope observations clearly presented for the first time trajectory of the Andromeda Galaxy. Data display the lateral motion of the Andromeda Galaxy in the sky. It's very slow, less than 0.1 milliseconds per year. In other words, it's almost straight towards the galaxy, and with blue shifted light, measured approach speed of 110 kilometers per second. This all seems to suggest that they are flying towards a head-on collision. But a few years ago, preliminary analysis by the Gaia Space Observatory revealed that the actual trajectory of the Andromeda Galaxy may have a certain angle, enough to avoid a head-on collision. And researchers are starting to realize that the attractive forces of other nearby galaxies maybe push the Milky Way and Andromeda Galaxy. Initial forecast treat this collision as a simple volume problem, but actually, our cosmic neighborhood is much denser. The situation is also more complicated, but in this galaxy detective case, there is a key suspect, the Large Magellanic Cloud. Great Magellan clouds are dwarf satellite galaxies currently orbiting the Milky Way, although much smaller than Andromeda and the Milky Way, but the quality is still impressive, about 10% to 20% of the mass of the Milky Way. Models that have simulated future collisions for years. We don't even take into account the effects of the Large Magellanic Cloud. People thought it was too inconspicuous. Can't affect the Milky Way and Andromeda Galaxy. These two behemoths. Thiel, an astrophysicist at the University of Helsinki, Dr. Sarah pointed out that early research, only the most likely values of each variable are considered. We often miss the Large Magellanic Cloud. Such participants. But new data shows that the Large Magellanic Cloud is no spectator. He himself is hurtling towards the galaxy. Its attractive forces are still tugging at the outer reaches of the galaxy. Sarah's team discovered the attractive force of the Large Magellanic Cloud with the Milky Way perpendicular to the approach direction of Andromeda Galaxy. And this attractive force, strong enough to significantly alter the trajectory of the galaxy. It is this attractive force perpendicular to the silver wire, interfering with the motion of the Milky Way, greatly reduces the possibility of merging the two. Sarah explained that, essentially the Large Magellanic Cloud, it may be nudging the galaxy, driven him off the predicted collision path. In this cosmic interaction, there's actually another participant, the Triangulum Galaxy. It's the third largest galaxy in the local group. It's a spiral galaxy. It is about half the size of the Milky Way galaxy. Early studies considered the attractive forces of the Triangulum Galaxy. Find it. In fact, it will increase the number of galaxies, the probability of merging with the Andromeda Galaxy, because it will pull the two galaxies together. Sarah's new research also confirms this. If you only include the Triangulum Galaxy, the probability of collision will be higher. But if you combine the Triangulum Galaxy and the Large Magellanic Cloud at the same time, it all counts. It's the exact opposite. Large Magellanic Cloud, vertical attractive forces will dominate, will reduce the probability of collision overall. It's a bit like two cosmic currents affecting a drifting ship. A current pushed the ship in the direction of collision. The other strand pushes it off course. What was the end result? It all depends on the relative strength and direction of these two forces. The key is that scientists, also aware of the uncertainties in observational data, like all these galaxies, current position, speed and quality, could lead to significant differences in future outcomes. Even Andromeda, minor error in lateral velocity, or a slight deviation in the mass of the Milky Way, on a timescale of billions of years, triggers a butterfly effect. The only way to understand this uncertainty, just accept it, then run a lot of simulations within the scope of observation, setting slightly different initial conditions for each simulation. Let's see what the possible outcomes are. 2025, from Helsinki, a team of scientists in Durham and Toulouse just published a new study in Nature Astronomy. They ran 100,000 set of future scenarios. Each set of simulations predicted the next 10 billion years, Milky Way, Andromeda Galaxy, movements of the Triangulum Galaxy, and the Large Magellanic Cloud. Here's the thing, they didn't rely on a set of best guess parameters, but let the key factors change within its full range of uncertainty. Research shows that a total of 22 different variables were involved, and those variables include the galaxy's current speed, the distance of each galaxy, and the mass of their dark matter halo. Dynamic friction is also taken into account in the simulation, that is, when the galactic dark matter halo interacts. Generated resistance. This resistance gradually depletes the energy of the galaxy's orbit, could lead to galaxy mergers over time. Make use of all this data. Supercomputer at Durham University. Run in groups. After the simulation is completed, a startling picture emerged. Collisions that were once considered inevitable. It's no longer inevitable. Instead, it's a head-on collision to a skim, to the result missed up close. The researchers counted the frequency of each major outcome. The results can be broadly classified into 3 categories. The first category is about 40-5 billion years later. Direct head-on collision occurs. The probability is about 2%. Only 2% of simulations. The drama of early predictions has emerged, and the timing is also as expected. In these rare cases, 2 galaxies in 5 billion years or less, almost head-on collision, merge quickly after a pass, and that's basically what Hubble predicted earlier on. The second type is advanced distance rubbing, eventually merged 70-10 billion years later. The probability is approximately 48%. That is to say, nearly half of the simulated scenarios will eventually be merged. Analog display. The 2 galaxies will pass by at close range. They're probably hundreds of thousands of light years away. This close encounter would seriously damage their structure. Tidal forces stretch their spiral arms. It also triggers the formation of new stars, but it will not immediately lead to a merger. After the first close encounter, they will be separated again, over billions of years. Dynamic friction will gradually consume the energy of their relative motion. Let them orbit each other in decay orbits, eventually merged after 80-10 billion years. This lengthy merger, not as crisp as a head-on collision. It may involve multiple passes. The mix of stars will also be more chaotic, but eventually a merged galaxy will form. That's a pretty good outcome. Means that the slow merger is indeed the Milky Way. Favorable candidate for fate. The third set of outcomes is no collisions for at least 10 billion years. The probability is about 50%. The Milky Way and Andromeda will pass by, will not collide. They may have had one or more long-distance encounters, like flying 1 million light-years apart. On a cosmic scale, that's a close miss, but the two will never be closer. At this distance, the attractive force between them is too weak, not enough to pull each other together. In this case, the Milky Way and Andromeda Galaxy may be loosely surrounded by each other, or very slowly move away. Even if it will eventually merge, it could take 200-30 billion years, and even longer. So, what's going to determine these different outcomes? Here's the thing. The aforementioned Large Magellanic Cloud and Triangulum Galaxy. Analog display. If you ignore these smaller galaxies, and the uncertainty it brings, will draw old conclusions. The Milky Way and Andromeda will collide rapidly, but once you include them, the situation has completely changed. Here's another interesting possibility. The Milky Way may have encountered Andromeda before. Merge with the Large Magellanic Cloud first, Research shows that, in the next 2 billion years, the merger of the Milky Way and the Large Magellanic Cloud, it's almost inevitable. The Large Magellanic Cloud is much lighter, will be swallowed by the Milky Way. When the Large Magellanic Cloud, when merging with the Milky Way's stellar disk and dark matter halo, it will bring its own quality, including the transfer of stars and dark matter to the Milky Way. This would make the Milky Way more massive. The center of gravity is also slightly shifted. These factors could further affect it later. Interaction with Andromeda Galaxy. Current simulations already incorporate this process, but still found in many scenes. Andromeda Galaxy. Ultimately, it will not fully merge with the Milky Way. At the same time, the Triangulum Galaxy may also eventually be involved in the merger. In some scenes, Triangulum Galaxy, it may merge with Andromeda first, then join the Milky Way. After a slow merger with Andromeda Galaxy, formed star system, the whole interaction is very complex. 4 galaxies of some mass are moving in the attractive force field of the local group. The attractive force of the Large Magellanic Cloud, plus uncertainty of the motion vector of Andromeda Galaxy, means that this cosmic catastrophe is not inevitable. These different scenarios will give us familiar cosmic structures and solar systems. What's the impact? The first thing to emphasize is that galaxy collisions and car rear-end collisions. The explosions in Hollywood movies are different. Most of the galaxies are empty. Even a head-on collision, the probability of a star or planet actually colliding is also extremely low. Contrary to stars and planetary systems, only under the influence of new attractive forces change the trajectory. The simulation results also show that, during the merger of the Milky Way and Andromeda galaxies, the probability of any stars actually colliding is almost nil. If the Earth still existed, possible, will not feel the catastrophic effects of a collision solar system, or will continue to be in the merged planetary system. Safe business, or it will drift into intergalactic space. In either case, until then, humanity has almost certainly found a new home, unaffected by galactic events. In the merge scenario, something that's bound to happen eventually, that is, the fusion of supermassive black holes at the centers of 2 galaxies. After the merger, a black hole about 4 million mass of the Sun at the center of the galaxy, Sagittarius a star, and the center of the Andromeda Galaxy, about 100 million mass of the Sun, will sink towards the center of the star system. Under the action of dynamic friction, they will rotate around each other, eventually merge into a much larger black hole. This massive black hole merger will release a strong wave of attractive force, and when the gas is inhaled, the core of the star system may temporarily become an active type. These phenomena may make the merger, the entire sky of the galaxy lit up. In addition, collisions of gas clouds, it could trigger a new round of star formation and supernova explosions. But since the solar system is far from the center of the galaxy, it is not directly affected by radiation outbursts. At most it will be exposed to some extra high energy cosmic rays. Life on Earth might not even notice it then. So the puzzle remains. Will the Milky Way and Andromeda collide and merge? Or just pass by? This problem is far from solved. Astronomers are expecting new data, especially Gaia, the latest satellite observations of the Andromeda Galaxy's motion. These data, perhaps further narrowing the uncertainty of its trajectory. So far, we're still going about 402,000 kilometers an hour. Fly towards the neighbor. And this reminds us again, as new data becomes available, big cosmic truths can change rapidly. The future of the galaxy, it's not a pre-written apocalyptic script. It's an unfolding story we're just beginning to understand, and future astronomers will continue to be filled with awe and curiosity. Watch it develop.